Hello and welcome to the Quality Excellence channel. I'm Mayank Agarwal, and in today's Lean Six Sigma session, we're covering Chapter 29, Design of Experiments, also known as DOE. Today, we're diving into Design of Experiments, or DOE, a powerful methodology that might sound intimidating, but trust me, it's incredibly useful and surprisingly accessible. DOE, a tool that helps us understand and improve the world around us, one experiment at a time. It's about systematically exploring possibilities and finding the optimal solutions to complex problems. DOE isn't just for scientists in labs. Although they certainly use it extensively for research and development, it's for anyone who wants to solve problems, whether you're in a boardroom, a classroom, or even your own kitchen. Think about it. From baking cookies, where you might tweak ingredients to get the perfect texture and flavor, to making hospitals safer by optimizing processes to reduce errors and improve patient care. Instead of guessing what works, which can be time-consuming and often leads to inconsistent results, DOE gives you a structured way to test ideas and get real answers, providing a clear path to improvement. Think about your morning coffee, that perfect cup you crave to kickstart your day. Is it the bean, the origin, the roast level that gives it that special something? Or is it the grind, the fineness or coarseness? Or perhaps the water temperature that matters most in extracting the optimal flavor? DOE helps you find out fast by systematically testing these variables and identifying the key factors. It's the backbone of quality improvement programs, driving efficiency and effectiveness across various industries. Like Lean Six Sigma, a methodology focused on reducing waste and improving processes. DOE is instrumental in making processes smarter and more efficient, leading to significant cost savings and improved outcomes. Rather than poking around and hoping for the best, relying on trial and error, which can be incredibly inefficient, DOE tells you exactly what to test for maximum impact, ensuring that your efforts are focused and yield the most valuable insights. This saves time by eliminating unnecessary experiments and focusing on the most critical factors, money, by optimizing processes and reducing waste and effort, by providing a clear roadmap for improvement and eliminating guesswork, crucial in any business or project where efficiency and effectiveness are paramount to success. By learning DOE, you become an active problem solver, equipped with the tools and knowledge to tackle challenges head-on, not just a bystander, passively observing problems without knowing how to address them. We'll break down the basics with real-world examples, showing you how DOE is applied in various industries and everyday situations. No PhD required. We'll keep things simple and straightforward, focusing on the core concepts and practical applications. All you need is curiosity, a willingness to explore new ideas and challenge assumptions, and a desire to make things better, to improve processes, solve problems, and create positive change in the world around you. Let's get started, shall we? And see how DOE can transform the way you think and work. Get ready to unlock the power of experimentation and discover the secrets to continuous improvement. So what is a designed experiment? It's a planned test where you change specific inputs to see how they affect your results. Instead of just watching what happens, you take control, changing variables on purpose to learn what really matters. The key idea, y equals sign fx. Your output, y, depends on your inputs, x. DOE helps you figure out which inputs have the biggest impact and if any of them interact in surprising ways. For example, maybe your coffee only tastes great when you use a certain bean and a specific water temperature together. Designed experiments let you build a model of your process so you can predict and control outcomes. It's about turning on the lights, moving from guesswork to real understanding. With DOE, you're proactive, designing robust processes from the start. You might think, I already have lots of data, can't I just use that? After all, you've been collecting information for quite some time, and it seems like a waste not to leverage it. Not so fast. Jumping to conclusions based on existing data can often lead you down the wrong path. Historical data is often messy, incomplete, and riddled with inconsistencies, and wasn't collected to answer your specific question. It was likely gathered for a different purpose, under different conditions, making it difficult to draw accurate conclusions for your current needs. It's like trying to guess a recipe from a blurry photo. You might get some of the ingredients right, but the proportions and techniques will remain a mystery. You can't untangle what really caused the result. The relationships between different factors are obscured, leaving you guessing at the true drivers of your process. Designed experiments let you change one thing at a time, isolating the impact of each variable, or several in a planned way. allowing you to understand how they interact with each other. So you can see what truly matters. You can identify the critical factors that have the biggest impact on your desired outcome. Trial and error is slow, inefficient, and often frustrating, and can miss important interactions between variables. You might stumble upon a solution eventually, but you'll likely waste a lot of time and resources along the way, and you might not even realize you're missing key connections. DOE is like building a 3D model of your process, allowing you to see all the angles and interdependencies. Not just taking snapshots. It's about understanding the entire system, not just isolated moments in time. The power is in the plan. A well-designed experiment is far more effective than haphazardly collected data. You decide what to test, how to measure, ensuring you gather the right information in a structured way, and what you want to learn before you start. This clarity of purpose ensures that your experiment is focused and efficient. This eliminates bias, ensuring that your results are objective and reliable, and gives you confidence in your results. You can make decisions based on solid evidence, not gut feelings. With DOE, you move from hoping for good outcomes, which is often unpredictable and unreliable, to engineering them. You gain the ability to proactively shape your results rather than passively accepting whatever comes your way. That's the key to real process control and improvement. It empowers you to optimize your operations and achieve consistent, predictable results. Many people try the one factor at a time approach, change one thing, keep the rest constant, and repeat. It feels scientific, but it misses the big picture, especially when factors interact. For example, the best coffee might need both a coarse grind and high temperature, but OFAT would never reveal that combo. DOE, especially factorial designs, tests all combinations of factors at once. With just a few more tests, you get way more information, including those hidden interactions. It's like mapping the whole landscape, not just walking the edge. DOE is more efficient and powerful, showing you the true optimal settings. OFAT can leave you blind to the best solutions. By testing factors together, DOE uncovers the real drivers of performance. It's the smarter way to experiment. Let's focus on the superstar of DOE, design of experiments, the 2 circumflex K factorial design. This powerful tool allows us to efficiently explore the impact of multiple factors simultaneously. It's a cornerstone of modern experimentation. K is the number of factors you want to test. Think of these as the variables you're manipulating in your experiment. And 2 inches means you test each factor at a high and low level. This simplifies the analysis and allows for clear comparisons. We are looking at the extremes to understand the full range of impact. For 3 factors, that's 2x2x2 equals 8 runs, a manageable number for most experiments, covering every possible combination of high and low levels for each factor. This ensures a comprehensive exploration of the experimental space. No stone is left unturned. In just 8 tests, you learn which factors matter most to your outcome. This is where the efficiency of the 2 circumflex K design truly shines, and crucially, how they interact with each other. These interactions can often be more significant than the individual factors themselves. For example, let's consider making popcorn. Test time, power level, and brand of popcorn at 2 levels each. Perhaps short versus long time, low versus high power, and 2 different brands. You'll see not just which factor matters most in popping the corn, but which combinations of time, power, and brand pop the most kernels, giving you the highest yield and best quality. Main effects plots show at a glance which factors have the biggest impact on your results. Are you better off with high or low power? Interaction plots reveal if 2 factors work better together than they do individually. Perhaps high power only works well with a specific brand. If lines cross dramatically in an interaction plot, you've discovered a powerful combo that significantly boosts your results. This is where real optimization happens. These visual tools make it incredibly easy to share your findings with your team, communicate results, and make data-driven decisions. The 2 circumflex K design is remarkably efficient, highly systematic, and reveals critical insights that you'd almost certainly miss with a less structured approach. It's the go-to method for designing quick, yet incredibly powerful experiments that deliver actionable results. With just a handful of runs, carefully planned and executed, you get a surprisingly complete and nuanced picture of your process and the factors that drive it. That's the magic and the power of factorial design. It's a true game changer for anyone seeking to optimize their processes. Let's dive in and see how to set one up, step by step. Ready to design your own experiment? Here's a simple recipe. First, define your problem and set a clear, specific objective. Next, pick your response variable, the y you'll measure. Make sure your measurement is accurate and reliable. Brainstorm all possible factors, excess, that could affect your outcome. Narrow down to the most likely suspects, the vital few. Set practical high and low levels for each factor. Choose your experimental design. 2 circumflex k factorial is a great start. Decide if you need to repeat any runs to check for natural variation. Write down your plan objective, why, factors, levels, and design. Now you're ready to collect data and run your experiment. Good planning is your secret weapon for success. Let's use DOE to tackle a real problem. Improving hand washing in hospitals. Our goal, why? Increase the percentage of proper hand washing by staff. We pick 3 factors: dispenser type, old pump versus new automatic, dispenser location, by the door versus next to the bed, and sign type, text only versus graphic. Using a 2-cubed factorial design, we set up 8 combinations across different hospital wings. For a week, we track compliance in each area. After analyzing the data, we find that automatic dispensers and bedside locations both boost compliance. The graphic sign helps a bit, but the real breakthrough is the interaction. Automatic dispensers work best right next to the bed. This insight would be missed with OFAT. DOE gives the hospital a clear data-driven strategy to improve safety. That's the power of designed experiments in action. Running the experiment is one thing, analyzing it is another. Statistical software like Minitab or JMP makes DOE easy and accurate. Just enter your factors and levels, and the software generates your experimental plan. It randomizes run order to avoid bias and helps you track your data. After the experiment, enter your results and let the software crunch the numbers. Instantly, you get clear tables and graphs showing which factors and interactions matter. Visuals like main effects and interaction plots make results easy to understand and share. Software takes the fear out of statistics and empowers you to make smart, data-driven decisions. Before you go, here are some final tips for great experiments. Document everything: your plan, assumptions, and anything unusual during the runs. Validate your measurement system before you start. Unreliable data ruins results. After analysis, run a few confirmation trials to make sure your findings hold up. This builds confidence that your changes will work in the real world. DOE transforms problem-solving from guesswork to science. By testing factors together, you uncover what really drives performance. With user-friendly software, anyone can plan, run, and analyze experiments. Be curious, ask questions, and use DOE to improve your world. Science is for everyone, so go experiment. Thanks for joining this journey into the world of designed experiments.